The flight times, T minutes, between two cities can be modeled by a normal distribution with a mean of 75 minutes and a standard deviation of sigma minutes. On a particular day, there are 64 flights scheduled between these two cities. It is important that we know what are the given information in this problem, such as the mean, which is 75 minutes, a standard deviation, which is unknown, and n number of flights. Now let's take this information to solve the first problem. Given that 2% of the flight times are longer than 82 minutes, find the value of standard deviation. So what we can do here is to try to visualize the problem by drawing the normal curve where our mean is 75 and there's a score here is 82, and above that score is 2%. This is the area or the probability, and you can convert this into decimal. And these are what we call the x-scores. You can also equate this to our z-scores. If you remember, our z-scores have the mean of 0, and all the scores here to the right are 1, 2, 3, and to the left -1, -2, -3. The importance of this z-score is that we can use that to find the value of our standard deviation. We have the formula z equals raw score minus the mean over the standard deviation. So with this, we can find the standard deviation to be equal to our score here is 82 minus the mean 75, and then we look for our z-score. So how do we get our z-score? Our z-score can be obtained by using your inverse normal function of your calculator. Okay, it will require you to encode the area. So is the area 2%? No, the area is from this point to this point, which is 98%. So when you're asked to encode the area, you will encode 0.98, and the mean retains to be, because we're not our mean you just choose the default there 0 and the standard deviation 1. You will get a z which is equal to 2.053 to check 05375. Okay, it goes on and on. So this is what you're going to use. So you can save this so that you won't have to encode all the numbers or the digits here. So, but for the sake of showing you what C is, let me write 2.053, etc. Okay, this will give you a standard deviation which is equal to 3.408401 and more digits to the right. So you save this because you might be using this later on. So to write our final answer for the standard deviation, we write standard deviation equals 3.41. So this is for the final answer uh, for this question. But then when you will be needing to use your standard deviation, you have to use the original value, this one that you saved. Okay, so let's do the next problem. Find the probability that a randomly selected flight will have a flight time of more than 80 minutes. Okay, let's visualize the problem again. The mean is 75 and the time is 80. And we would like to find out a flight time that is more than 80 minutes. So we are after this area, this probability. What is this? So this is paper 2. We can use our calculator. So we're looking for the probability that your time, t times, t minutes, or t is greater than 80. So what function of calculator are you going to use? You will use normal CDF, cumulative, because it is from this point to somewhere. You use PDF on problem that involves word like exactly. So let's say what's the probability that time is exactly 80. So that is where you are going to use PDF. In this case, it's more than 80 minutes, so we will use CDF. So in your calculator, it will require you to encode the lower bound. So the lower bound is 80 and your upper bound is infinity, positive infinity. And then your mean, since your score, the score you gave is in terms of x or x scores, so all the rest will be x scores, so 75. And then your mean is what you have encoded to be 3.408. So this is what you saved. Now this will give you a probability. Please always write the first answer that you got from your calculator. 0.0711193 and so on. Because in case you forgot to save the first answer, you can actually encode this original answer. It will give you still a number which will be equal to a number which is rounded off to three significant figures. So here is 0.0712 to three significant digits. Remember, this zero, which is a placeholder, is not significant. So here in this number, we have three significant figures. Given that a flight between the two cities takes longer than 80 minutes, find the probability that it takes less than 82 minutes. Okay, the best way again to understand the problem is to put it in a normal curve. So we have here our mean and our scores given here 80 and 82. It says given that the flight between the two cities takes longer than 80 minutes, so it takes longer than 80 minutes. What is the probability? What is the probability that it takes less than 82 minutes? So these are less. Now we're looking for the intersection. Now another thing to take note of is that this is a conditional given that. So given that, so this is a conditional probability. And to write this simply, this means we're looking for the probability that our t or x t is less than 82 minutes given that the time is greater than 80 minutes. And to solve this kind of problem, this is simply the same as getting the intersection by formula. You can look it up in the formula booklet, that conditional probability. You get the intersection of the two, which is 80 over this probability that t is greater than 80. Now we have solved this problem in part B. So we can write our answer here. We can already write the probability. So that's why I told you to save it. So it's 0.071193 and so on. So if you save that, you will just write the variable that you use to represent it. Now for this one, for this part, okay, what are we going to use? What function of your calculator? Can you tell? It is normal CDF. So your lower bound is 80, your upper bound is 82, and the mean is 75, and the standard deviation is 3.408. Okay, so this will give you an answer which is 0. So with this, it will give you an answer 0.05119 and so on. So let us put it here 0.05119 and so on. Okay, it will give you this result 0.719075, and you have to give your answer to 3 significant digits because you cannot give it as exact. So that's the thing there. You cannot give it as exact, then give it in 3 sig fig. 719. Find the expected number of flights that will have a flight time of more than 80 minutes. Now, what kind of probability are we talking about? Since we have our discrete value, number of flights, and expected number, we are dealing with binomial distribution, where x is binomially distributed with n, remember, and this is probability. So using the given and the things we have solved already, so our x is binomially distributed with number of cases 64, and the probability of success for 80 minutes has been solved. Where is that? Here in letter B. So the probability that it's 80 minutes is, let me check, 0.711, 0.71193 and so on. So that's why you need to save it. So this is probability, this probability is the probability that the time is greater than 80 minutes, and you solve this in part B. Okay, so we use the formula for expectation, which is NP. So we'll just multiply 64 by 0.71193 and so on, and we shall get 4.556353 and so on. So that is equal to 4.56 intrinsic fig, 4.56 flights. In reality, since it's discrete, normally we'll just say around 5 flights, but this requires 3 sig fig now, so we can just say around 5 flights. But let us keep our answer this way. So in most of the exams given, they write the answer in 3 sig fig. Find the probability that more than 6 of the flights on this particular day will have a flight of more than 80 minutes. Again, it is important that you know the kind of probability you are dealing with. So it talks about flight, number of flights. This is a discrete variable. Therefore, this will require binomial distribution. In contrast, on the first examples, first three questions where it asks about time, and time is continuous variable, we are dealing with normal distribution. Now, let's take a look again at the problem. We're looking for a flight that is more than 6 minutes. So let's say we're looking for the probability of flight. Let's call our flight as y is more than 6 minutes. Then this would mean we're looking for the probability, more than 6 flights, sorry. So we're looking for a flight that is equal to 7, or probability that the flight is equal to 8, and so on until probability, the highest you can have for the flight is 64. Okay, so as you can see, so greater than 6 are 7, 8, 9, and so on. This is cumulative. Therefore, we will be looking for the binomial CDF. It will ask you the value of n, which is 64. And let me check what else will it ask you. The probability of success, that's success for having 80 minutes, probability of this is already given in letter B, I think. So it is 0.071193 and so on. And then your lower bound is not 6. 6 if it's continuous. But since this is discrete variable, greater than 6 is 7. So your lower bound is 7. And upper bound is not infinity because it's discrete. It is equal to 64 according to the problem. So solving for that will give you 0.169119, and let's round this off to 3 significant digits, 0.169.